First, we're going to focus on using the standard algorithm for multiplying multi-digit numbers. So, step one, you want to line up both of your numbers so that they match their place value. So ones, tens, hundreds. Step number two, we're going to multiply 428 by the 7. So I'm going to do 7 times 8. I put my 6 down here and I carry my 5 to my tens places. I'm doing 7 times 2 next, and then I have to add the number that I carried over. So I have 14, 15, 16, 17, 18, 19. I write my 9 down here and I carry my 1 up here to my hundreds place. I'm going to multiply the 7 by the 4 and add the 1. So 7 times 4, 28, 29. I have no other numbers, so I'm going to write both numbers down here at the bottom. I have completed my 7. And if you're doing this on notebook paper, I like to cross these out so I know that I'm done with them. If you have a whiteboard, you can erase them. And I'm moving on to my 3. Before I start multiplying, since I'm done with the 7 in the ones place, I have to put a placeholder in my ones. And we're going to fill that in with a 0. I'm going to do 3 times 8. Carry my 2. I'm going to do 3 times 2 and then add the 2 I carried. And then I'm going to do 3 times 4. Again, I'm out of numbers, so I'm writing both down here. And the place value, as you notice, has shifted. But I'm still making sure that my numbers are staying lined up with their place value. And then I'm going to lastly add them together. So 6 plus 0, 9 plus 4, carry my 1, 1 plus 9 plus 8, carry my 1, 1 plus 2, and my last number, I'm bringing down 1. And that's my final answer. The second way I'm going to show you how to multiply multi-digit numbers is using partial products. For partial products, I'm going to break apart each of the factors before I multiply them. So for 37, I have 3 tens and 7 ones. I'm going to take each of these numbers and multiply it to the 428. So on the left side, I'm going to break this into its parts. I have 4 hundreds, 2 tens, and 8 ones. 400 times 30, 20 times 30, and 8 times 30. I'm going to multiply the digits first, starting with the 4 and the 3 to make it a little bit easier. So I have 4 times 3, which is 12. Now I'm going to go back and add my zeros. I have 1, 2, 3. 1, 2, 3. I'm going to do the same thing for 20 and 30. 2 times 3 and add my zeros. 1, 2. And 8 times 30, I'm going to do 8 times 3. Add my 0. Now I'm going to take each of my answers and I'm going to add them together, making sure I line them up so they are in their place values. Now I'm going to take that 428 and I'm going to multiply it by the 7. Again, I'm breaking down the 428. 400s times 7, 2 10s times 7, and 8 1s times 7. 4 times 7, and I'm going to add my zeros, 1, 2. 20 times 7, 2 times 7, add my 0, and 8 times 7. Again, I'm going to take each answer, I'm going to add them together, lining them up so that they are in their correct place value. Now, to get my final answer for 428 times 37, I need to take both parts and combine them. So I have 12,840 plus 2,996. Again, lining up to make sure they are in the right place value. And that gives me a final answer of 15,836. The last method I'm going to show you how to use to solve multi-digit multiplication problems is the area model. The area model is similar to partial products. We're going to break down the numbers to make it easier to multiply. So starting with the 428, I'm going to break it apart into its place value. So I have 4 hundreds, 2 10s, 8 1s. For 37, I have 3 10s and 7 1s. The area model uses boxes to help keep numbers organized. Just like partial products, I'm going to multiply each number to find its answer. So I have 30 times 400. 3 times 4 is 12. Add my zeros. 1, 2, 3. 30 times 20, so I have 3 times 2. Add my zeros. And then I have 30 times 8. 3 times 8. Add my 0. I'm going to do the same thing with the 7 down here. So I have 7 times 400, 7 times 4. Add my zeros. 7 times 20. So I'm going to do 7 and 2. Add my 0. And 7 times 8. Now I'm going to add all of my numbers together. Making sure that I take each number and line it up with its place value. So 428 times 37 equals 15,836. The first method I'm going to show you to divide large numbers is using the standard algorithm. So I'm going to take this number, 56,784, and I'm going to put it inside the bracket, and I'm dividing it by 48. First, I'm going to take 48 and see if it can go into 5. 48 is larger than 5, so it goes in 0 times because it doesn't fit. 48 times 0 is 0, and I'm going to subtract. 5 minus 0, 5. I'm going to bring down my next number, 6. Now I need to see if 48 can go into 56. To do this, I'm going to create a multiples list for 48. This is useful for large numbers, and it will help save time instead of having to multiply each number to see if it fits or not. So to do that, I'm going to write 48 out on the side, and I'm going to add 48 each time to get my list. And I'm going to stop right there because I know that I need 56. 56 falls in here, and that means that 48 can only go into 56 one time. I'm going to place my 1 up here. 48 times 1 is 48, and I'm going to subtract. I do have to regroup. So 4. I'm going to bring down my next number. Now I need to see how many times 48 can go into 87. So I'm going to look back over at my multiples list. 87 comes in between here. So again, it can only go in one time. I'm going to add my 1 to the top. 48 times 1 is 48. I'm going to subtract. I have to regroup again. And I'm going to bring down my next number. Now I need to see if 48 can go into 398. So I'm going to come back to my multiples list and I'm going to keep adding 48. Okay. 398 is going to be right here in between these two numbers. And I'm going to count how many multiples that was. So I have 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to put my 8 up top. 48 times 8 is 384. I'm going to subtract again. Bring down my last number. Now I need to see how many times 48 can go into 144. 144 is right here. So it goes in 1, 2, 3. Place my 3 up top. It's 144. Subtract. And that leaves me with 0. So my answer for 56,784 divided by 48 is 1,183. The next strategy I'm going to show you to divide large numbers is using partial products. Partial products kind of start out the same as standard algorithm. We take this 56,784 and we put it inside of the bracket. On the left side, I'm going to put that 48. And then on the right side, I'm going to draw like this long tail. Partial product is useful because it allows you to use bigger multiples of 48 that we know to break this big number down until we reach 0. So I have my multiples list on the left side. I would recommend doing this at the beginning of the problem. So I have 48 and I added 48 each time to get the next multiple. And I know that we need 56,000. Well, if I take this 48 times it by 1,000, that would give me 48,000 because I need 48 times 1, which is 48. And I would add those 3 zeros. And then I would subtract. I have to do a little bit of regrouping. And now I'm left with 8,784. Well, 48 times 100 is going to give me that 48 times 1. And I'm going to add 2 zeros. So that gives me 4,800. I'm going to subtract again. I have to do a little bit of regrouping again. And now I'm left with 3,984. Looking at my multiples chart to see what would get me close to 398, because I know I have up to 400s here in my regular multiples list. I know that that would come here. So that's 1, 2, 3, 4, 5, 6, 7, 8. 8 times. Well, if I take that 8 and I stick a 0 on it, now I have 80. So I have 3,840. Another way for your multiples list is you could draw it like a T-chart, and you could label them. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I'm going to subtract over here. And now I'm only left with 144. So going back to my multiples list, I know 144 is here, and that's 3 times. So I'm going to write a 3 off to the side and subtract, leaving me with 0. Now I'm going to take all of these partial products that I found over here on this right side, and I'm going to add them together. So 56,784 divided by 48 is 1,183. The last strategy I'm going to show you to divide large numbers is the area model. This is very similar to the partial products and uses the same steps, but it gives you another way to organize your numbers. So starting with 56,784, I'm going to put this number inside of a box. To the left of the box, I'm going to put the 48. Just like partial products, 48 can go into 56,784 1,000 times. So I'm going to write the 1,000 up top. 48 times 1,000 is 48,000. I'm going to subtract. A little bit of regrouping. And that leaves me with 8,784. Now I'm going to take this number and I'm going to put it in another box next door. So 8,784. I know that 48 times 100 is going to make 4,800. So I put that 100 up top, 4,800 here. I'm going to subtract. A little bit of regrouping. And it leaves me with 3,984. I'm going to take that 3,984 and give it a new box. I know that 48 can get us close to 398 because we have our multiples list and we know that it's here. And that's 1, 2, 3, 4, 5, 6, 7, 8. And if I add a 0 to make 80, 48 times 80 is going to be 384 with a 0 on the end. So 3,840. I'm going to subtract the 2. And that leaves me with 144. I'm going to make a box for the 144. And I know that 48 can go into 144 3 times. Put my 3 on top, 144, and I'm going to subtract. That leaves me with 0. Now I'm going to take all of my answers on top, and I'm going to combine them. So I have 1,180 and 3. And that gives me a total of 1,183. So 56,784 divided by 48 is 1,183. This method is very good if your student is getting confused when they're doing the standard algorithm and they're not lining up their numbers correctly. This helps them keep the numbers together with each group, allowing them to see the changes until you get the answer.